Okay, well, good evening, everyone. My name's Paul Fraser. I'm a principal landscape architect and urban designer from Atkins. And about a year and a half ago, I was involved in the review of the way that our London team and our international businesses approach our master planning services. And before I get into the tool and its application, I wanted to just dwell for a few minutes on this sort of image. I mean, this is the sort of thing that we would find in any of our design documents, any sort of design-led documentation that might come forward for a major master plan. It could be a third of that size, it could be 3-4 times that size, but ultimately the kind of content is the same. It sets out to communicate a vision to the client and show them what our kind of spatial sort of design approach is for the site, and what sort of thing they could expect to see if they took this vision forward. What it doesn't do, or what it doesn't have, is any underpinning in terms of data and analysis. And Atkins, along with many other practices out there, put themselves out as a sort of a multidisciplinary practice, and we pull together multidisciplinary teams to give the client a robust approach to master planning. But the reality for something like this is that if the client wanted to workshop this with us, and we would make design changes, that for us to then come back to them with things like population numbers and utilities demand and transport demand and all this sort of thing, it would have to be remeasured. The measurements would go to our planning department. They would give us updated population numbers. That would go to our utilities team, who would analyse that and come up with updated utilities demand and that sort of thing. And we sort of have these loops of activity, and I'm sure that's the same within any other major practice. So this set us thinking really about the revolution in BIM that is happening predominantly at a kind of a individual buildings level, whereby you have a central model, or a central asset, if you like, which all of the teams contribute to, and that in turn brings forward all of the data. So everything from utilities kit to materials to roof area for contractors and facade and everything else would all come from the same model, and one design change would knock through the whole package. So we started looking for an approach along these lines that we could take forward for our kind of larger scale master planning work, up to and including the sort of metropolitan scale. We looked at various packages, and some were more suitable than others. Autodesk openly said to us they thought it was a square peg in a round hole for us to use Revit, so we didn't take that forward. And we ended up talking to a small company based in London called CityCAD, or Holistic City. CityCAD are a young architect called Chris Sharp, who I think comes down here every now and again, and a Russian mathematician called Svet, and their band of merry men. And what they've done is to build a tool specifically for master planners, and I think they worked with the University of Westminster, which is my old university, through the development of the tool. And what it does is to through a 3D interface, which is very simple and intuitive to work with, allow you to track a whole range of parameters. In fact, every metric that you would want to sort of look after and nurture as you developed a master plan in one place and in one program. So one change to one building, a floor in one building or 3 buildings would knock into population, trip distribution, all of this sort of thing. So, okay. In parallel with this, Atkins at our kind of top group level were commissioning from within the company a series of carbon tools, and our chief executive Keith Clark at the time was interested in putting together a portfolio of tools across our whole spectrum of businesses that allowed us to respond to some of the questions we were starting to get from our clients about how they respond to the kind of climate change initiative and the sort of carbon benchmarking of their projects. And some of my colleagues in the planning team and sustainability put together a brief, which was ultimately accepted, to develop a master planning tool. So what we did was to commission CityCAD and work closely with them to develop a custom version of their application, onto which we've bolted a web-hosted database which holds all of our kind of carbon intelligence, if you like, and that talks directly to CityCAD and the CityCAD sort of custom version of the CityCAD user interface. We've done a lot of development on the environmental capability of CityCAD. It was fairly crude before, But what we've done is to talk to all of the various specialisms within Atkins to work with them on exactly what, if we were asking them to work within this model rather than in their own typical sphere, what are the kind of knobs and bells that they would want to see and be able to manipulate to make the tool valid for their use. So the tool in practice, I don't know whether anyone's seen it up and running. This is Atkins' custom version of it, and there are three basic parts to the tool, or its user interface, and I'll just quickly outline them. This bottom section is where the program is drawing in all of the intelligence from the database. And the way it works is when the tool was developed, a UK data set was put together by a sustainability team. We've since done one for India, and we've got other teams worldwide working on parallel data sets. So you tell CityCAD where in the world the project is, and that then extracts the relevant carbon factors based on types of buildings, the fleet of vehicles, all of these sorts of things that would have a bearing on the carbon footprint. The right-hand panel is the specific building, street or element that you're interrogating at the time, and the sort of features in here that you're able to manipulate and change are sensitive to what it is that you're actually interrogating. And then on the left is our kind of summary carbon panel. There goes another minute. Oh. So the panel on the left is our summary carbon panel, which is tracking the four key constituent parts of an overall carbon calculation, so transport, waste, utilities and land use. And so this gives us a kind of a ready reckoner at any point. And the beauty of this, of course, is that because it's all based on a 3D interface, you can be sat with a client and the design team, and any change to any building or any element, which can all be done quickly and intuitively, knocks right through the data set and changes all of your calculations on the fly. This is what the front end of our web-mounted database looks like, and these are the various criteria under which the data set's structured. I could bring one of our specialists down here and they could talk for hours on the ins and outs of this, so I'm going to skip through this fairly quickly. But the point is to show you that it's been developed by, it's not a tool that's been developed by the designers for the designers. The designers have led a team of technical specialists who have been effectively framing the thing to make sure that it will give us robust calculations, but in a way that designers can use and clients themselves can understand and access. And that's what the carbon factoring matrix looks like, which sits within the database. So each of these is an individual data point, which correlates to all sorts of other things. So, I mean, a couple of our sort of previous speakers have all really touched on the idea that a new approach to master planning is needed, and that was something we were very keen on from the outset. And for us as a company to do something where we could all work together in a way that really brought multidisciplinary together in the way that it ought to work, and where one change from one member of the team was an instant change and not something that involved us waiting 3 days for them to go through their loop of activity. And it also allows us to bring our clients with us a lot more strongly. And also to optimise designs in a much more meaningful way. So for instance, you can see at the push of a button what the implication of a design change is on a whole series of factors. Whereas before you would make the design change and then you wouldn't understand the implications until the rest of the calculations had been done. So I'm going to talk very briefly about an early pilot project for this. It's the Low Carbon Cities project, which has involved us working through DFID with two city authorities, Mysore and Madurai, in India, and it's been led by our planning team predominantly, but with a little bit of input from me. It's really geared towards India as a whole addressing the challenge of their trajectory of urbanisation. The idea that they're 30% urbanised in 2010, and from I think the McKinsey report says that for them to keep up with their economic potential, they're going to have to build something like the equivalent of a new Chicago in terms of floor space every 10 years for the next 40 years. And at the same time, they're trying to manage this transition from sort of industrialised, rapidly industrialising city with some digital economy, which they're very well known for, up into this more sustainable form of urbanism, which is where they need to be for them to unlock the financing that they're trying to access to help them along with some of these projects, which is often energy and climate change related. in terms of the bilateral agreements that exist between the European and American nations and the developing countries. So here's a slide on the development context. What we saw and what they were building typically is very extensive areas of sterile villa development, entirely residential, with one large chunk of commercial and public services and that sort of thing tucked in one corner. So no real consideration of things like distribution of their social infrastructure and what that meant for walkability and car use and all of that sort of thing. Now, Madurai is the first one, and the two cities, we looked at them on a very different scale. So this was very useful for us in terms of the tool, because it allowed us to pilot both the tool's macro and sort of metropolitan scale capabilities, but also the kind of 3D side of it, and then the more sort of touchy-feely neighbourhood planning. So what we can see here is the sort of central core of Madurai, which is the current extent of development, and then the extent of their planned development, I think from till 2040, which is something in the region. I think it was 4 million people. And our planners went through a sifting process of looking at what development had already come forward, looking at what land was left over and sat within their core strategy. And then we, through looking at various different approaches to that development, we started talking to the client about the idea that they should and could intensify hubs of development around the public transport network that they were bringing forward. So pretty straightforward stuff. But what we were able to do with the tool, was to extract these hubs in their correct spatial location and plug them into CityCAD, and to assign them the correct land use based on the urban typologies and land uses and everything else that was sat within the database from all of the research that our Indian colleagues had done and the data set that had been put together. And so the model effectively then sees these mixes, and you can see one of the mixes being interrogated here. That's a land use mix for one of these cells. And it sees them spatially, so it recognises their centroid, it recognises their location. And one of the things it allows us to do is to run a live transport trip distribution model, actually within the model itself. And so that gives us a daily trips and a transport carbon output. So for instance, it gives us the ability to do a quantitative assessment of the relative locations of these hubs, and use that as part of the optimisation process. And if you translate that into something like the UK design context, and the last speakers talked about sort of analysing sites, if you took something, a major driver of trips like a hospital or a school or something like that, you could quite easily use this methodology to assess the carbon implications of relative locations of that to other urban centres that sit around it. And so what we were able to do was to go through a kind of an optioneering process based on some key themes. So here we've got one that looks at connectivity and also some adjustments to the land use mix and employment density, and see how that affects the relative carbon merits of each of the hubs. And the same there for connectivity. The transport model allows us to look at things like quality of public transport and actual highways distances between nodes. I'll just skip through these. So again, taking the kind of summary high-level outputs from the carbon panel for any of these options at any given time, we're able to give them a system of outputs, and this is the sort of panel that our planners use to give the clients a very kind of easy to understand and track summary of how different approaches to development would yield results for them. So Mysore, coming down a scale, is much more of an urban neighbourhood or district, depending on your terminology, and this is the kind of business as usual. So we have very large developments of entirely villas of slightly varying plot sizes, and then you can see up there this will be the sort of public services and commercial plot, and that's where all of the schools, all of the shops, all of the surgeries and everything else happens. So everyone travels right across this thing to access that, and the irony of their sort of bus propelled by clean fuel mantra in the top corner. So this is what it looks like when you build that base case in CityCAD. So the client can relate to it because it's the look and feel of development that they're already delivering. But what we're doing is to start setting up the data behind it to give us a valid base case from which to optioneer. And this is the sort of thing we can output when we start to do that optioneering. So by defining different buildings or bits of floor space as different land uses, one of the things we can do is to heat map the 3D model by any parameter at any time. And that parameter could be carbon, it could be cost, it could be trips generated, it could be thermal demand or utilities demand. So it gives us a very quick way of doing what is actually a very technical optioneering process, but in a way that is instantly visually accessible by a client anywhere. And then, I mean, in this case, because we're outputting 3D data, albeit this has had a little bit of a sort of mild makeover by someone with a felt tip pen. Ultimately, what we're doing is exporting a 3D representation of a development that the client can understand. So we're not working in a spreadsheet and trying to then communicate. Going back to the very first slide, working in a spreadsheet and then trying to communicate a visual spatial strategy to a client. We're always in the realms of the 3D and the visual, but we're also tracking all of the data as we go. And that's it. Thank you.